Hey there, good day. Welcome to Solvebeta today, and we're going to be talking about matrices. This is the first class of my summer coaching, Solvebeta summer coaching for students in SS3. Now, we're going to be talking about matrices. Now, what is the concept of matrices? Matrices is actually the plural of the word matrix or matrix. Matrix is a rectangular array of numbers. It's a rectangular array of what numbers? Imagine this. Let's say these students, Bola, Adi, Michael. Let's say these are their test scores in maths and physics. These are their test scores. 90, 95, 20. Okay. Adi is brilliant. 85, 70, 90. Now we can arrange this way. We can arrange it this way. 90, 80, 70, 95, 85, 90. So this is what you call a matrix. When you have another one, you call it the matrices. Or we call it matrices rather. So matrices is a rectangular array of numbers. Look at it, rectangular. We arrange the numbers in form of a rectangle. That's what we're talking about when we talk about matrix. It's very, very important. It has its application in advanced mathematics, and it is used in programming and more. So the first thing you need to know about matrix is this. I'm sure you have written that down. Now, the way this class has been designed is to ensure flexibility. You can rewind the video, watch, pause, watch over and over again if you have any question. And in the one-on-one support session, you can meet me. I will explain some things to you. Now, let's continue. We have said matrices is the rectangular. A matrix is a rectangular array of numbers. Matrices involve rectangular arrays of numbers. What you should know about matrices is that there are different types of matrices. You have a column, row matrix. Let me begin with row matrix and column matrix. Row matrix and column what? Matrix. Then there's a square matrix. Square matrix is when the amount of rows is equal to the amount of columns. This is square matrix. Square matrix. The amount of row. You have row and column. This is row and this is what? Column. Very, very important. Row moving sideways, column moving up or downwards. Row moving sideways, column moving up or downwards. So this is a row, this is a what? Column. So a square matrix has how many rows here? 1, 2. 2 rows, then 2 what? Columns. That's why it's a square matrix. Also, this is a 2 by 2 matrix. It's a 2 by 2 matrix. Why? Because it has 2 rows and 2 what? Columns. Another example of a square matrix. Let me use a 3 by 3 matrix. 1, 1, 0, 1, 1, 1, 2, 1, 3. So this is a 3 by 3 matrix. What do you mean 3 by 3? It has 3 rows and 3 what? Columns. So it's also a square matrix. Square because it has 3, 3. But this is not a square matrix. 1, 2, 1. This is not a square matrix. Why? How many rows does it have? It has 1 row and it has how many columns? 1, 2, 3. So this is a 1 by 3 column. 1 by 3 matrix rather. 1 by 3 what? Matrix. 1 row. You write the row first before the word column. The row is written first. The amount of row is written first before the word column. So this is 1 by 1, 2, 3, 3 matrix. 1 by 3 what? Matrix. Very, very important to take note of that. Now take a deep breath and look at it. I've said so many things which I would like to revisit. I said that matrix is a rectangular array of numbers. It's a rectangular array of what? Numbers. And we have your square matrix. Square matrix will mean that the amount of rows is equal to the amount of columns. This is your row moving sideways, and this is your what? Column. This is a 2 by 2 matrix, 2 rows, 2 columns. Because you have 2 rows and 2 columns, it's called a square matrix. If you have 3 rows and 3 columns, it's called a what? Square matrix. If you have 4 rows and 4 columns, it's also called a what? Square what? Matrix. Are you with me? Then we have your row matrix. A row matrix is a matrix that has only one row. Only what? One row, just like this. This is a row matrix. This is a row matrix, row matrix, row matrix. It has only one what? Row. The column matrix has only one column. It has only one column. This one has one column. It has 2 rows, but 1 column. This is a 2 by 1 matrix. 2 rows, 1 column. 2 rows, 1 column. This one is a column matrix. Column matrix. Why this is a row matrix? Row matrix has only one row. Column matrix has one what? Column. Very, very important. Row matrix has one row. Column matrix has one what? Column. There's a lot of things to learn involving matrix. I'll try my best to begin and give you that foundation that you want to know. Don't forget, a row matrix has what? How many row? One row. A column matrix has how many column? One what? Column. I'm trying to look for example. Let this guide me. So I won't move. So there are so many other things to note about matrix. So many things. As we advance, we'll get to that. But this is the foundation of what? Matrix. We can add and subtract matrices. We can add and subtract what? Matrices. My goal of this class is to help you identify what kind of matrix we are dealing with. What is a row matrix, a column matrix, a square matrix, and help you add, subtract, and multiply, scalar multiply matrix, scalar multiplication. So those are what we'll be doing. Now, let's say we are to add this matrix together. Take note that you can only add matrices that adds the same amount of rows and columns. If you are told to add some matrices together, they would have the same amount of rows and they will have the same what? Column. Yes. You can't add a 1 by 2 matrix to a 3 by 3 matrix. You can add a 2 by 1 matrix to a 2 by 1 matrix, a 1 by 2 matrix to a 1 by 2 matrix. So this is a square matrix, 2 rows, 2 by 2, 2 columns. So if you want to add it's very, very simple. This entry will add this entry, this entry will add this entry, this one will add this, and this one will add with this. So this will give you 1 plus 2, 3, 1 plus 4, 5, 2 plus 1, 3, 2 plus 1, 3. So this is the addition of these two matrices. This is the addition of these two what? Matrices. What if it has to subtract? What if it has to subtract? The same thing that applies to addition applies to subtraction. You can't subtract two different matrices. They must be the same. Either they are both square matrices or they are both there can be both square matrices, or they can be 2 by 3 and 2 by 3, or they can be 3 by 2 and 3 by 2. The two of them must be of the same shape, if I can use that word. Now, how do we do this? You take this way, subtract the corresponding entry here. The position of this is the first one, Abi. This is also the first one. So you say this is 3 minus 1. which is what? What's 3 minus 1? 2. You can say 0 minus 2 minus 2. 1 minus 0, 1. 1 minus 2 minus 1. 1 minus 1, 0. 1 minus 1, 0. So this is the subtraction of both what? Matrices. Is that easy? To solve matrices is that what? Easy. It's not difficult. Very, very, very easy. Very, very easy to subtract what? Matrices. Very, very, very easy. Very, very easy to subtract what? Matrices. Very, very what? Easy to subtract what? Matrices. Very, very what? Easy to subtract what? Matrices. Remember I said that you can only subtract like matrices, meaning that they must be of the same shape. I can use that word loosely. You can't do this. You can't be told to do this. 3, 1, 2 plus or minus 1, 1. No. This is a what by what matrix is this? Remember we said row, then column. How many row? 1 by how many column? 1, 2, 3. 3 column. 1 by 2 column. So you can't add or subtract this. You can't add or subtract this. Very, very important. Now we go to scalar multiplication. What do we mean by scalar multiplication? This is what we mean by scalar multiplication of matrix. It's very, very important. Scalar multiplication is different from multiplication of matrix. It's scalar multiplication, meaning multiplying matrices by a scalar by just one digit. Okay, let's say we have this matrix. If we have this, A is equal to 1, 4, 2, 1, 3, 3. B is equal to 1, 1, 0, 0, minus 1, minus 4. And it has to find 2A. This is scalar multiplication. It has to find 2A. 2 multiplied by the matrix A. It will be 2 multiplying all the elements here. Or like I used earlier, all the entries there. 2 multiplying all the entries there. So 2 will multiply A. 2 will multiply 1 rather to get 2. 2 will multiply 2, 4. 2 will multiply 3, 6. 2 will multiply 4, 8. 2 will multiply 1, 2. 2 will multiply 3, what? 6. So this is what you call scalar multiplication. When one digit, one number is multiplying all the elements in the what? Matrix. Scalar multiplication. So if you are asked to find, let's say, in fact, you can be told to even do this, not multiplication now. B divided by 4. B divided by 4 will be, it will be all the matrix here, all the entries rather, all the entries, or all the elements, see the same thing, divided by 4. So this would be 1 over 4, the first one. The second one, 0 divided by 4, which is 0. The third one, minus 1 divided by 4, minus 1. So now let's go to the second row. Second row, 1 divided by 4, 0 divided by 4, minus 4 divided by 4, which is what? Minus 1. So you can be told to do this. This is what we mean by scalar what? Multiplication of matrix. In fact, you can be told to find 3A, no, let me use this. Let me use this one. 2A minus 2A minus 2B. We have done 2A. 2A is what? This is the result of 2A. 2, 4, 6, 8, 2, 6, right? 2, 4, 6, 8, 2, 6. Minus 2B. Minus 2B. I've not multiplied B by 2. So I'm going to do this. So I've done that. I can now multiply each of these by 2. So I have what? 2, 8, 4, 2, 6, 6, minus 2 has to multiply with the entries there. 2, 0 minus 2, 2, 0 minus 8, right? Yes. So now let's subtract. Sorry about that. Let's subtract. I'm trying to confirm this. So let's subtract. 2 minus 2 is what? 0. 4 minus 0, 4. Don't forget, this will subtract this. Okay, this minus this minus it. Each element here we subtract, or it will minus the corresponding elements in that same position in the other matrix. 2 minus 2, 0. 4 minus 0. Don't say 4 minus 2, no. 4, the position of 4 here is this. Yeah. 6 minus minus 2, that's 8. Why is it 8? 6 minus minus 2 is 6 plus 2, 8. 8 minus 2, 6. 2 minus 0, 2. 6 minus minus 8. 6 minus minus 8 is 14. That's 6 plus 8. Let me confirm. 2 minus 2, 0. 4 minus 0, 4. 6 minus minus 2, 8. 8 minus 2 here, 6. 2 minus 0, 2. 6 minus minus 8 is what? 14. So you can be told to do that. See that matrices is very easy. You just need to follow the what step. You just need to follow the step. Very, very, very what? Easy. What else can you be told to do? What else? You can be given something like this. I'm giving something like this. You consult with my textbook. You can be giving something like this. You can be giving something like this. Okay. Trying to see what you can be given. I'm trying to see this because I want to make this introductory class very, 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 very basic before we go ahead to something else. Okay, let's take a look at this question. Find x, and I must say matrices is very, very important. It always produces questions in JAM each year. JAM and WAEC. You can't say that you won't see any question under matrix when you write your WAEC. I think I would have to write this very well. I have to clean this and write it very well so that you can, because some students get confused when you have lines like these, 2 lines. So let me write everything on this straight line. So it is very, very, very good with this my handwriting. So if you have this 5, okay, find x. You have to find x if 5, you have this matrix here, 4, 7, 3, 3. This is a 2 by 2 square matrix. Minus 2, 2, 1, 3, 4, 2 is equals to wx, yz. You have to find x. It's not difficult though. It means that the scalar multiplication of 5 and this minus the scalar multiplication of this and this will produce a matrix that these are the entries. What is this entry here that is in the first row, second column? First row, second column. This entry that is in the first row and second column, what is it? That's just the question. Don't be bamboozled by you having algebraic terms here. You just want to find the matrix that is in this position when you do this. So what do? We say 5 times 4 Let me just multiply it. You do this. 5 times 4, 20. 5 times 7, 35. 5 times 3, 15. 5 times 3, 15. 5 will multiply all the entries there, minus 2 will also multiply all the entries there. You can do it this way. Put the minus here. Let 2 multiply all the entries. We have 2. 2 times 1, 2. 2 times 4, 8. 2 times 3, 6. 2 times 2, what? 4. Then is equal to W, Y, X, Z. sorry for that. So now to subtract this, 20 minus 2, 18. 15 minus 8, 7. 35 minus 6, that should be 29. 15 minus 4, 11 is equal to W, Y, X, Z. So now, which of these numbers is in this position is 7. So X is equal to what? 7. It's as easy as that. It's as easy as that. Now I'm going to leave you with something to do. Something very simple like this to do. These are the questions. You do not break any sweat in solving these questions. Very, very simple. It looked very serious, but it's not serious. And that's one of the things you must take note of. In solving mathematics, don't for any reason think it's difficult. The moment you believe it's difficult, you'll not be able to solve the problem. When you this problem is difficult, you'll not be able to solve it at all. You'll not be able to solve it. So X is 7. Now let me add the bonus because there's a class after this class still under matrix. Let me add the bonus before I give you something to try. Then when we meet in the one-on-one session, we are going to discuss more. If you have any question to ask from this, or maybe you've furthered your study on matrices and you have any question, you can ask. But there's still another class on matrix. But let me give you this bonus. It's called transpose of a matrix. Transpose. I don't know if you heard the word transpose. Transpose of a matrix. Transpose of a matrix. Transpose of a matrix. Now the transpose of a matrix, if we have A to be a matrix, and let's say these are the entries, A, B, C, D. Let's say these are the entries, or they are the elements. The transpose of this matrix is represented by A raised to power T. A raised to power T. The transpose of this matrix is simply reordering this matrix this way, or rearranging this matrix this way. This will still remain this. This entry becomes this entry here, AB. Are you saying this? AB, C, D. This row becomes a column. This row becomes a what? Column. This is a row, AB. AB will now write as a column, AB. This CD, AB, will now write as a what? Column, CD. And the same thing holds for a 3x3 matrix too. It's not just a 2x2 matrix. It also holds for a 3x3 matrix. The rows become the column, and the column will become the what? Rows. Very, very important. Please take note of that. That's what you call a transpose of a what? Matrix. A transpose of a what? Matrix. The row will become the column will become the row. So if we have to transpose this matrix, let's say we have this matrix here. We have B to be 1, 1, 3, 5. B transpose row is 1, 1. It will become a column 1, 1. The second row is 3, 5. It will become the second column 3, 1, 5. Now, if we transpose this same matrix, if we transpose B transpose, remember we transpose B to get what? This. If we transpose this one that we transpose, or let's transpose this B transpose again. You know, this B has been transposed. We want to transpose it. We'll get B. If you transpose the matrix that they transpose, you get that what? Matrix. This is what I mean. This is B. I've transposed B. I got what? B transpose. If I transpose B transpose, I will get what? B back. Let's check that. This is B transpose. Let me transpose if I will get B back. Row 1, 3 become column 1, 3. row 1 5 become what? Column 1 5. Is this B? Yes, it's B. So it therefore means that A transpose transpose is equals to what? A. The matrices, the transpose, how do I explain it? If I transpose a matrices that the transpose, I get the matrices. I get the matrix. Sorry if I'm using the word matrix. Anytime I use the word matrix for one place, it's just because I'm used to calling matrices. Matrix is one, while matrices is what? More than one. So if I transpose a transpose matrix, I get what? The initial matrix. Please take note of that. Very, very, very important. Very, very important property of what? Matrices. So I leave you with this. I leave you with this as something to do. I leave you with this as something to do. You are going to first transpose the following matrices. Transpose this. Don't forget there's another class, there's the part 2 of this class. We're going to transpose this. I can write the matrix this way. Instead of using that bracket, I can use this bracket. So transpose this matrix. Let me give you a 3 by 3 matrix to transpose. 1, 2, 5. 1, 5, 1, 0, 8, and 9. So transpose this matrix. A. Then B. Let me look for something that you can do addition and subtraction of matrices. Let me see if you can add and subtract matrices. I hope you're enjoying the class. I hope you're learning something. I want to give questions for my book, so I don't give something that is okay. So try this. 3, 2, 4, 1, 0, 7 plus 1, 3, 1, 2, 1 minus 3. You do that. You can do that. Then B1, B2, if A is equals to 1598, B is equals to 8773, you have to solve the following. Okay, A, B, yes, this is the second question of this. You have to do the following. So there's question A, you have to question that question. There's question B, you have to question another question B. So you find 4A, I find 4B, I. You're in SS3, you should be expecting more problems. This is 7. 2A minus B. Question 3. Is A minus B equals to? Is A minus B equals to B minus A? So this is a question for you. Is A minus B equals to B minus A? Is A minus B equals to B minus A? So make sure you do this, and if you have any question, ask me in the support session. See you in the next one. Thank you.